All right, so I'm so sorry about that. Just a little sidetracked from my side. Um, all right, so let me see what are we up to right now. So from the last class notes that we finished, the basic, the standard normal using calculator, right? So we basically know how to compute all of this on a calculator. And the next thing we're gonna do, like I said, that we're going to continue on the calculate to calculate the basic z-score based on the chart and the calculator. So let me go to the next part. All right, so this one will be kind of like different from what we're doing. All right, so let me go to objective four and continue. All right, so please ask question if you have any parts that you don't understand, so I can simply help you guys out with that. That's very important that you ask questions. Um, because some of this part will be on the exam. I mean, on the exam you might see some question like that. Okay, so the question's going to ask us like, hey, I would like to fight like the C such that the probability on the left-hand side will be equivalent to like 0.2546. So what that means is if I take the probability and I want it to be on the left sides, I want to find the C values, right? I want to find C such that the P on the left side on the left is equal to 0.2546. Okay. So we cannot randomly guess. We actually get to, like find the exact values. So you need to find the z-score, right? The z-score. So this is what we have to figure it out, what the z-score um that's satisfied like a C less than 0.2546. Let me just put it down real quick. Using this syntax, uh, using that one. This is, I just want to make sure we know what it is. Okay. On the calculator. I have noticed that many of you haven't started like Objective 4, even if we almost finish it. Um, so please try not to finish it in a single day. That's impossible because you're gonna spend a lot of time working on it. If you go back to all the notes to see what it is. So if you haven't started yet, please start the Objective 4 as soon as you can. That's very important. The objective four is due like 2 days before the exam, so we still have like less than 2 weeks to get it done by Sunday, October 19. Just want to let you know that there's no extension for objective four because it have to be finished. You have to be done like 2 days before the exam on October 21st. Okay, so now let's compute the z-score of 0.2546. Let's see how it goes. We got the z-score will be 0.66. So using a calculator, you can figure it out. Well, you know what? Um, when I do like 0.66, when the z-score is positive, the z-score is positive. Um,
Think small. It has to be small, right?
so
No,
so meaning that so when the z equal to like 0, for example, so the p of z uh less than 0 is basically 0.5. It's going to be the same thing as the p of z greater than 0. So you can always take 1 minus to find the less than, but very likely that if you want to find the z-score of 0.2546, when you hit enter, you got like 0.66, right? 0.66 doesn't seem to be on the left side, so you have to change the side for that, right? Very likely. So on a calculator, we get z of
what what is the biggest factor that we can take out?
0.2546.
I mean, it's not obvious. Three, like a trait. I don't know if you know this, but to understand if a number is divisible by three,
I don't think that's worked this way.
if the sum is divisible by three, then the number is
Okay.
7 plus 5 is 12.
Um,
12 plus 3 is 15. 15 is divisible by 3, so this has to be divisible. So let's take out 3 and see that. So what is 375?
let me use a table and see if that's going to give me the same results. 0.66 on the left side. Just give me 0.7454. Yeah.
Right. So basically,
So meaning that you're gonna get the negative value. So this is what we have on the calculator, um, which is um,
out of all of this, even if
that one.
like a triangle,
But
we saw like after like last time, I think.
so this is like so this is bigger than 0, and then if it's less than 0, that's gonna be 50%. Okay, so the z-score that we have is something like this one.
Now you're gonna have to like this, and this is a little more palatable.
Okay, so this is like this is 0, z equal to 0. That's the curve. And then you're gonna get like 50% on the left side. So this is 50%, and this is also 50%.
Four times 2, 8. So 2 is our guy. 125. Let's see.
All right.
Let's go.
So meaning that if it's like greater than 0.66, it should be on like this side, something like that. Okay, so you might have to change the side, right? Change to negative
That means that
66.
now you have to do a little bit of the power rule. Just in the sense
0.1 actually.
you want to move this up.
So
Or I mean, if you don't, if you
so it must change to the negative side to get to the answer, which is negative 0.66. Um, the curve, the z, the standard normal is always symmetrical.
and how we apply our formula for
Is symmetrical.
So we know that for the difference of cubes, like we know that for
Okay, so making sure we have Jehold's property. So meaning that the probability on the left side it's gonna be reflected in the probability on the right. So if you get like something 25%, the z-score on the left should be negative, should be around here, right? Should be around here, 25%, something like that. Okay.
So the special forms, you just need to cut up numbers.
So
either like and honestly
in other words,
make sure like never memorize
when I grab this, so there's the 25% started from like this part, and then it's gonna count all the way.
so that it could happen.
So this is 25%.
So you like just write them down. So
Okay, so the z-score have to be negative in this case, so we're gonna get like negative 0.66.
so that equals to one.
Okay, so it's right here. Let me try another example and see what it is. Um,
Oh, that was fine.
the same thing for you can also take like 1 minus this on a calculator. So the z of 0.8186, you don't have to do this, but this is more than 80%. So you're gonna change the side to like 0.80, 0.91, something like that.
I don't think that's right.
And then you should be able to get it right correctly. Okay.
No. It's not, X is included in there. Look at, I'm talking about A squared. You have A is equal to one.
So
A in this
in
case,
other words,
side ups. So if we have A squared, then I'm being not just like X squared.
if I go for like 81%, for example,
We have
so 81% is like something like that.
and this is when five squared X.
So this is 81%. Okay. And then the z-score have to be positive. Not really. We need to understand the questions because the probabilities go from the left side.
I see what
The probability of the z was like less than c. So this is the probability to go to the left.
like association of like symbols.
The area go to the left side. The area or the probability, right? To the left.
And then like there's only like you just have to like
Left side.
rework it.
So the left area provided was like 81%, uh, around 82%. So 82% meaning that it cannot be, the z equal have to be positive because like so when the z equal to 0 we got 50%. So something positive it should be more than 50%. Right? It cannot be on the left side. The left side will be negative z, the right side will be positive z. So it should generate a positive z in this case. Okay. But that part is have to be a negative z. So in this case, you're gonna do like positive of 91. Okay. So all we have to do just, well, making sure that understanding questions, sometimes we change the side for that, but you have to watch out if the side was greater than or less than.
Yeah, it's like you're not even like doing anything
It's 0.91.
rewriting it in a finalized version.
I'm not quite sure yet, but I would say some book they would do something like that. Maybe your calculator can do the z of 1 minus 0.8186. You gotta get something like 0.81, right? So you're gonna subtract the probability of like this. You can also do this
A special form in the sense that you will
on a calculator. I would say
where at most like you have to take the like some factor out, like some number, like in this case,
and then that's gonna give us
and that is
literally the same answers as 0.91 something, right? So you don't have to change the signs. we just make sure we understand what the question asks. And then to get the corresponding answers, you usually have to take 1 minus from the Z calculator to get to the final answers that we provided. It's like 81.86%, 81%. All right. So the same thing for they can do like the Z of 1 minus 0.2611. You got like 0.64, negative 0.64. So we can check the answers quickly.
There's gonna be a special form.
Yeah, we can start from 0.64. It doesn't matter anyway. So
There's gonna be a special form, or
yeah, the same thing. We can use a calculator. Tends to take the Z of 1 minus 0.7257. You get 0.6.
like we haven't even done the quadratic formula for it yet, so.
Yeah.
Same as we have.
Okay, something like that.
The total is also one. Yeah.
Yeah, this one's kind of like hard. This is more fancy, so we have to be extremely careful from what we're doing so far. So it's go from like 2 psi or something.
Well, I mean, it's different. I wouldn't say more difficult. It's just gonna be different. That, yeah, it's, I mean, they're both intro courses, so it's not gonna be, like, if you take any,
All right.
I'm sure there's definitely going to be.
So we can't figure it out like the
But
so you got like 2 sides
depending on how.
of so the probability of a C less than Z less than negative 0.84 equal to 0.1559, right? So we can rewrite this in terms of the probability of a Z less than the site equal to doesn't matter because the probability at any specific point of the continuous model is all equal to 0. So we can put the equal or less than or equal to, it doesn't matter. So we're gonna take negative 0.84 minus probability of Z less than C, right? So we got this 1.119. Right, so we need to find the on the calculator we need to figure it out. Hey, what is the P of negative 0.84? So we can figure it out on the calculator. So which is 0.2004 minus P of Z less than C equal to 0.1559. So I can solve for that. I can solve for the P of Z less than C equal to 0.2004 minus 0.1559. So we subtract that.
Because like that's, if you think about it, it's again thinking of the absolute value as the distance of whatever you have inside of it from the 0 line up to.
We got this equal to like 0.0445.
Similarly.
Yeah, you can change the sign. You can we can also do like Z of 1 minus that.
Smallest possible value.
We should get negative 1.701, right? So that means that we can take
values of that. So that really leaves us with
the
a
Z.
situation where that's say, do you have an example maybe at hand or a question? Oh, wait, this is an equation. Okay, that's one for equation. Oh, equations. Okay, then let's do equations.
So you get this part equal to negative 0.17.
So for actually equation for that, let's do 1 minus 10x.
Okay. So the answer is C equal to negative 0.17.
And that's equal to 5. Okay, so first step, leave if you want to get.
Okay, you can always check the answers if you get it right. You can also check the P of negative 0.84 minus the P of Z was less than negative 0.17. You got the answer is 0.1559. It's pretty close to what we got here. So that had to be negative 0.17. Check the answers. Okay. Are we good? All right. Any question? Do you need one more practice or are we good to go?
What this is telling us is that, okay, that means that I want
Any question?
1 minus 10
Yeah.
to be 10 units this.
Yeah, let me just go over one more example. This one might be on the exam. I haven't checked the exam question yet, but it's very similar to what we did over here. All we have to do is just making sure that we
Just of it is always that, okay, then we're gonna have two scenarios.
we have to rewrite
You're gonna have two possible values
that part in terms of like the subtracts of the bigger subtract the smaller, so you can rewrite this as
first
P of Z
is
less than Z, C minus
whatever
P of Z less than
is equal to
negative 0.87
why is it that
equal to
minus, and keep in mind
0.7834. Okay.
Put your parentheses here. Like we're talking about minus 1 minus.
All right. So after that, we're going to compute the P of Z less than negative 0.87. So you get a 0.19215. And then you subtract this equal to, I'm sorry.
We apply it to this situation.
Let me just erase this.
1 minus 10x, or the absolute value of 1, I'm putting the parentheses here just for kind of the sake of it, but.
And then equal to 0.7834.
The absolute value of minus 1 minus 10x.
And then you're gonna take like.
So essentially what you're doing is
this, and then we add both sides by 0.1925
then what you want to do
215 on both sides.
You will get two different values.
I think we can route it to like
you will have two solutions
0.1922, something like that.
So this you will have
just making sure that we're not gonna count like 5 decimal point. The question only asks that you route up to like 4 decimal place.
This is number 1. And then
all right, we're gonna add them up and let's see how it goes. We're gonna take 0.1922 plus 0.7834. We got this one is 0.9756.
And then divided by minus 10. So
all right, so we're gonna get the P of Z less than C equal to 0.97 5556 doesn't matter anyway. So
in this case, you will have.
All right, you're gonna use a calculator to compute it. It's only give us the right area, so which is kind of sad. You're gonna take 1 minus 0.9756. This is how we're gonna find a p-value. Is all we look at the right part. Hold on, I think I'm missing out 0.9756. So you got 1.97.
And x is equal to
okay.
11 are solutions to this equation, both of them, right? Does that make a little more sense? Yeah. Just basically you, whenever you have, in like whenever you have an equation with that involves the absolute value, you start with just kind of getting the absolute value part all on one side.
All right, so that's the C that we have over here.
Two different scenarios where either you have the argument of the absolute value, which is what is inside the absolute value.
So we can always check the answer. Let's say we take like the P of like 1.97 minus the P of Z of negative 0.87. You should be able to get the answer is 0.96. Oh, hold on, let me check what's wrong.
It's actually not that much more complicated.
It's like 1.97.
We're really doing the same thing. So let's say that instead of this.
And then minus the P of Z of negative 0.87. Let's see. Yeah, we should get something like that, which is 0.87834. So the answer is 1.8, 1.97.
Just boils down to two different situations. Either
yeah, it should be good. All right. So I believe that's pretty much what we have. And now we're going to go to the standard normal curve compared to the normal curve.
One of the two is taken as the negative, and the other one is taken as the positive. Why is that? Because really, if we have the minus out here, we really could, if we multiply by -1 on both sides, and we get the minus over on this side.
So the normal curve like gives different mean and different standard deviation.
Each of them we have the possibility of one of them
and different standard deviation.
So, but the reason why we discard the other two options is because the option where
let me just put a little
negative.
A little space between them.
This. If we multiply by -1.
So the mean and standard deviation, they have syntax.
So it's the same.
The standard deviation I'm going to use this, and then the mean is going to use that.
The other option would be where 1 minus 10
okay.
is positive. And
so let's look at that. Below the graph,
and again,
in shade the region is represented power of 10, so like greater than negative 1.5.
Which really boil down to now for inequality.
You have to save this, right? You have to shape the standard normal. So we can always convert to the standard normal by taking the x
is smaller than a negative number, then that means that we have no solution.
Subtract the mean.
Bigger than a negative number, that means that
we can always shift the index back to 0 and 1. Back to the mean equal to 0 and the standard deviation equal to 1. And divided by the standard deviation. Okay, so that should be given from the question. So it says, well, you know what? It's given by the mean equal to 3. That's what the question says.
Again, try to think of this as almost like kind of like create like a table in your head.
And then
there's like 4 types of.
So I want to get the x. This is going to be the x.
They're not very different.
They're going to take the z, you're going to find the z-score, where we're going to get started.
So this means
you're going to take the x is negative 1.5.
Minus 10x. Going back to, you can kind of like think of it again, like what we were doing with the equation. So we have either the situation where
minus the mean was 3, divided by standard deviation was 3 as well.
Right? Or the situation where minus 1 minus 10x.
Okay, so now we can use the calculator to compute this. So negative 1.5 minus 3 divided by 3. I got the answers negative 1.5 as well. Oh, that's kind of weird.
Well, we end up here.
All right, so we just simply on the left side, so we're going to start from negative 1.5 over here.
institution number
And
two,
then I'm gonna go
which right,
shape the
different
region
way.
greater than, so that should be that one. Okay, as simple as this.
You're just saying
Yeah, just shape the region on the right.
1 minus x.
So greater than negative 1.5.
So you don't
So
have
we're
to
gonna
go to
pick the
whole thing.
regions on the right,
Skip over
right?
this.
So the area should be on the right.
Whatever you have as the number that your absolute value is smaller than is going to correspond to
So we can simply just shape that
a blended inequality where 1 minus 10, the argument
and we convert it to the standard normal.
value for that number.
So the U exactly the same probability, so it doesn't make any difference between this curve and that curve. The U like exactly the same probability of about like it's greater than, so 1 minus is about like 93%. Okay.
-4
Yeah, we play the same thing. It's play the same games. Like
and
uh,
2.
we're gonna do divide 4 minus minus 2 because the mean was -2. The standard deviation is 4. We got 1.5.
410. It's x.
And it's greater than 4. I'm gonna show you the region on the right. I'm gonna check the answers quickly. Okay.
Under interpreting it, but after you see it, like we're really just like if you flip this on the other side, like if you were looking at
How can we type the standard deviations in the calculator so we could take less time to solve it? You don't type the standard deviations. We simply just convert to the z-score and then know what it is. So this question just need to convert to the z based on the formulas. The z equals to the mean minus standard. Just shifting the index back to 0 for the mean and the standard deviation equal to 1. As simple as that. Okay. All right. I'm not sure we answered your questions correctly, but let me know if I don't, so I can clarify more.
now
Yeah, we just play the same thing.
0. That's then 3.
Yeah, that we just simply convert it just like that question. You will definitely gonna see these questions like that on the exams, but I'm not sure about the final exams. But this question would definitely be on the second exams. I will literally have to spend times working on it on the calculator.
Either 1 minus 10x is bigger than 3, right? Because that's just looking at the right side. Obviously, like if a number is further to the right, that means that it's bigger. So we have bigger than 3. Or
So the question says like the mean equal to
we want
0.2,
minus 10x to be
and
further to the
then
left
the
side.
standard deviation is 0.05. You don't necessarily have to do that on the exams. Hold on, let me just change the marker, just making sure to use the correct markers on it.
Not the smaller, right? That's it.
So the mean was like 0.2,
Your other two.
and the standard deviation would be um,
And you solve that.
0.05. Okay. So we need to find the keyword at least 0.27 and want to find the x. So the x is at least, right? At least means greater than, right? At least is greater than. Okay. So we have the x equal to 0.27. So we convert to x greater than 0.27. We convert to the z-score. You don't have to show me work on the exams. We convert to the z. It's greater than, you're going to take the x, subtract the mean. The x that we had was like 0.27 minus the mean is 0.2 and divided by
1 was on this side.
0.05.
Minus 10x is bigger.
Okay.
So that ends up being
Yeah. we just have to convert from x to z by doing the columns.
smaller than 10. And on this side, we end up having, let's see, -3, -4. So we end up having x bigger than 4 times.
However, the calculators only give us the area on the left side. It doesn't give us the area on the right, so we're gonna take 1 minus the left. So I'm gonna subtract. Oh my God, I forgot. I'm missing out the p in this case. So let me just copy that part first.
Or
I forgot to put the p over here after you erase the whole thing.
this is what they are, like, this is just rewriting whatever this is in integral notation. And the key thing here is that we have a union of these two. Meaning that whatever value, as long as the
Oh
value
my
is one of
goodness,
the
I
two
just
that's
erased 7.
right,
All right, anyway, so I just rewrite what it is.
that,
So we're gonna
this
take
value
0.27.
bigger than this. I think there was in classwork, there was a situation where that was the case. That
I
just
forgot to write the
says
p, so which is why it's kind of confusing.
they kind of like overlap these two intervals at some point. What that means is that we're really just looking at anything from -infinity to infinity. So, I mean, if you leave it like this, like as a union of two intervals, that obviously that's like the big part of the question. But if there might be in that situation, you get like
And then we just
full
compute
credit
it
or
by
full
1
credit,
minus
like, okay,
p
so this is
less than.
-infinity. In this situation, that obviously doesn't apply because -2 is smaller. That's all the possible kind of combinations.
All right, so that should be like one. It's like one line answers on the exam, so I don't. The X should be given on a question. The X like at least followed by the keyword. At least the mean. The question gonna tell you like the means equal to something. That's the normal curve. And the question also give you the standard deviation. So the X should be like go by itself without any mean or standard deviation. Okay, so all right. So let me just compute this 1 minus the p. We're gonna take the divide of x. The x that we have was 0.27. It's go by itself without the mean, without the standard deviation. Subtract the mean is 0.2. And over the standard deviation is 0.05. And then let's see. You got 0.0807. Are we good?
Straight line up through a whole. So as long as you're looking for anything that is under that line or over that line,
Any questions so far? You just do this on a calculator.
it doesn't have a specific point. For all that you want to notice is you choose any point. You can choose the origin. You can always choose the origin if you want. I just go at any time, whatever the situation, I will choose the origin. That would be fine. What you want to do is for that specific situation, you want to plug in 0, like the origin. So 0 for y and for x. Like
It's like one line answer, so we don't spend times like too much on what it is. It's 0.0808.
are we talking about all the area that is over this or the area that is under it? So in this case,
Yeah, anyway, so it doesn't matter. You have to put 0 in front of the decimal point.
but that's just like.
Oh yeah. So because the word at least is greater than, right? It's greater. At least means greater than. Because the minimum, right? The minimum 0.27 or more. So that's have to be greater than. So the size greater than means that we have to take 1 minus that. So make sure you have to get it right. If you get like 0.9193, that is wrong. You have to take 1 minus that. Okay. So let me try another one. Let's see what it is.
So in this case, want to be careful because this is not, you don't, this line doesn't pass through it.
Yes. Left side. Look, it's the left side. This is the left side, right? The less than or equal to is on the left. The word at least
Another point,
it's greater than. So we have to take 1 minus.
quite nicely, so for x equals is gonna have value three, so yeah, that's correct. There you go. So that's your line. So now you're looking,
Okay.
is it over or under? So you take the origin, which indicates.
All right. So the same thing for that is exceed was like you're gonna convert to the z is greater than, right? Um, you're gonna take 780 minus the mean was 560
So in this case, greater than four. So yeah,
and over
the kind of the caveat is,
over the standard deviation was
but as long as it's not on the line, I guess that's, yeah, sure,
the standard deviation is 120. All right, so you gotta take 1 minus this, right? So the calculator only give us the area on the left, so you're gonna take 1 minus that. So you change to the left side. Less than, you're gonna take 1 minus.
So now you choose like say, well, actually, in this case.
Okay.
It passes.
So exceed means greater than. Okay. You're gonna take 1 minus the p of z less than something like that, right? This is the calculator.
And then you choose, in this case, you can choose the origin.
So where's my palm?
It's gonna be like right next to your, so you're evaluating the whole area.
Did I close it?
What happens is you said one bigger than four, that just doesn't make sense, right? So we're gonna be on the other side.
Oops.
Uh,
Yeah, I don't understand. It was went to different problem. We have so many different problems, so I'm trying to get back to the one that I have. So let me just answer it. Let me just answer that one. Okay. Um, I think I accidentally closed it. So I'm gonna take 1 minus the p of division 780 minus 560 over the standard deviation is 120. So you get like 0.003, right? Three, three, four, something like that. Okay. We good? For this problem, we just simply say at most, so you don't have to subtract. And then let me just do this question for you. Sometimes I accidentally just close out the question. So the word at most, so it should be less than, right? The max number we'd star 69 of fewer, right? At most is less than equal to. We don't count the equal sign. It's the probability at any specific point equal to 0 over any continuous model is too small to evaluate. So we can start with the z of p of z was less than 69 minus 65. Over the standard deviation 110. And then we should get it right. So you get 0.6554. Okay, that should be good. Yeah, 0.6554. All right, so let me move up to the next one. It's more advanced stuff, but it's actually pretty much the same concept. So this is advanced going to give us like, so just write up the mean first. The mean was like 219. And the standard deviation is 60. All right, so I want to have like less than, so less than 201 or more than like 237. So those are the x values, right? Less than this. And smaller than 237. Okay. So all we have to do is just simply rewrite the p of z less than 201 minus 219 over 60. And then the more than just like 1 minus, or I mean add. Okay, or I mean add. So we're going to add the p of the z was greater than, so we don't have a greater than, so we're going to take 1 minus. Okay, you got to take 237 minus 219. You do the same thing, divided by 60. Okay, this is like a p of more than, right? All right, we just compute on a calculator, should get it done for that. I'm going to take the p of like 201 minus 219 over 60 plus 1 minus p of z. I'm going to take the ratio between 237 minus 219 over 60 as well. All right, let's see, go get 0.764, right? Which is 76.42%. This should be good. Okay. Where's my calculator? Right? Yeah,
Yeah, you would just.
I think I have to do that again. So they close out 201 minus 2 is 119 over 60 plus.
I'm taking complex analysis next semester, so maybe I'll get back to you like 4 months or 5 months.
7
It is very I have.
10 over 60.
We work together from the
Right. I'm gonna get this.
Will act like a little
6.
maximum minimum in order. Yeah, sorry.
All right.
Now I know. Not always possible to rotate the illegal on the graph.
Okay, so that's pretty much what we um, have to be concerned.
When it works out nicely where you do this, it have.
Let me double check. Yeah, the other question just like that. It's not very complicated from what we have over here. Like between was sort of different. Let me work through like for one problem. Between. And after that I'm gonna move up to the other thing. So I think I don't have enough space.
Yeah, well, yeah, come back.
Move to the next one. So I want you to find the betweens of like 4 to 7 less than x less than 512. The x usually followed by the keyword at most, at least, betweens, less than, more than, greater than, fewer than, something like that. The mean and standard deviation should be taken separately. So you're going to get 467 degree, and the standard deviation is 25. So all we have to do is just simply take the calculator, which is the P of Z, we take divide, we take the second x first, 512 minus the mean 467 divided by 25, and we subtract the probability of a Z. I do the same thing, we hit divide first, and then take 427 minus 467 over 25. So we get like 0.9092, which is 90.93%. Okay. Yeah, it should be straightforward. Okay.
Bigger or than. 45 or actually, yes, negative. Just forget to put the million time. What did you for? Yeah, you transfer the negative because you transfer the
Less than the Z, less than what we have over here.
So you have
Oh, hold on. Oops.
so more than like 8 or
Yeah,
bigger.
we're gonna take like the P of a Z less than 512 minus 467 over 25. Just take take the bigger, subtract the smaller. Divided by 25. And then we subtract the probability of a Z was less than 427 minus the mean over 25. And then she got something like 0.90.
And they could have bigger or equal. So what does that tell us? About
0.9093. Okay, so that's pretty much what we have so far. And I don't think that's hard enough on the exams. I would say the hardest part was the expected value and the standard deviation. You're gonna do the opposite. You're gonna find a raw score. I'll let you go after these two questions, and then we'll continue on that on Friday. Then I'm gonna tell you the topics that we should focus on the exam. So now the questions ask, what is the minimum score needed to be top 25% of the test? So instead of we're gonna get the z equal to the x minus the mean, divided by standard deviation. So we can solve for x equal to the z times the standard deviation plus the mean.
So the what's the line again? Like, report the line. You have y bigger than, so y.
Okay, so the z should be given with the p, right? So z can be found using probability, right? Using the p, right? Probably given probability.
So when x equals 0, y is gonna be equal to minus.
Okay. So the question I'm going to give is like top 25%. So top 25%. So that is the P of Z is greater than Z equal to 25, right? The top 25%. So the hard part was like need to determine if the Z is negative or positive. So the top 25%. It's the Z on the right. So the Z have to be positive. It's positive, right? All right, so we can just compute it. So on a calculator, you can find the Z score based on this. You're gonna get 225. You have to take the positive part, which is 0.67.
Then that means that whatever the line was, and wherever that point was, like whatever that half line that point was in, it's gonna be the other half line. So in this case, like start by just draw the line. Well, no. So you want to plot it.
All right, you're gonna take the Z score equal to 0.67.
0 minus 2.
You're gonna identify the score. So the Z score is 0.67. 45.
So the coordinate point 1, 2 would be your other, like your.
Time the standard deviation is the standard deviation was 100
0
plus the mean is 500. So you compute on the calculator.
You're gonna have 1.
You're gonna get 567.4.5.
1.
Okay.
But,
567.5.
So
All right. That's what it is. I mean, just route out to 567, I would say. Okay. So we need to use the formula to solve for the x, and then you figure it out. Let's try one more. So something for that, we're gonna take whenever you see the bottom, so when you find the Z score, have to be like 1 minus. So the bottom 10%, you're gonna take the probability of the Z 1 minus 10%. Because the z will be negative. All right. So when you compute it, you're going to get negative 1.28. Okay. And then you can simply compute it like the x um, equal to the z times the standard deviation plus the x plus the mean. Plus the mean plus the average.
Oh, you're right. Hold on. Yeah, that's the one. That's great. I want to choose right. So now you want to choose the way to determine.
All right. So the z-score we got was negative 1.28. 2, just like one, maybe 1/6, whatever. The 4 decimal place. Time the standard deviation is 0.4 plus the mean was 9.3. Let's see how it goes on calculator. I got 8.7, 8.8.
And then the same for one. Sometimes like if you look around, sometimes it makes that switch for different.
Okay, so the bottom 10% you have to take 1 minus when you find a z-score.
Once you substitute that, I find the y on yes. Oh, that's what it.
No problem. Yeah. All right, so the top like is on the right. So it's on the right. You don't have to just take the z of 25%. You can get the z-score based on that. The z-score can be found given by the probability, like top 25%, the bottom 10%. And after we file the z-score, just multiply with the standard deviation plus the mean. Okay. I feel like that's pretty much it. Let me take attendance. I'll let you go quickly.
Or you just take a start point, you plug it in, and if it makes sense, then that's the right one. Not, then that's the other one.
All right. So Jasmina is here. Maliger. All right. Annie is here. All right. Rachel. All right. Selena is not here. Yeah, I think most of you will be here for sure. Sharns and Saminer, Sarah, Alexis, Yi, Motley. Motley's here. Motley. Okay, it's not here.
Either you have
I think the rest of you should be in class. All right, I'll see you on Friday. Have a wonderful day. Take care.
only these both out, right? Then you have a team that is